Okay. Talked about how to solve a system. Remember, a system of equations has two equations, two variables in each one, usually x and y, but we can use whatever letters we want, right? And for substitution, you took one of the equations, you got the x or y by itself, you plug that into the other to solve for one of the variables. Once you get one of the variables, you plug it back in to find the other one, okay? Now, elimination. The basis of elimination is if you take two equations that have some solution, and if you add them together to get another equation, that equation will have the same solution. So like for this one, let's say we solve this by substitution and we got x equals 2 and y equals 1. Which makes sense because 2 times 2 is 4, plus 1 is 5. 2 plus 2 times 1 is 4. If you add those two equations together, add the x's, add the y's, add the constants, you get 3x plus 3y equals 9, 2 and 1 work in that one. Same thing if you subtract them. If I took the first equation and subtracted the second equation, well, what's 2x subtract x? What's y subtract 2y? Negative y equals 5 subtract 4. 1. Does 2 and 1 work in that one? Yeah. So x equals 2, y plus 1. So we use that to solve systems using elimination. So what we're going to do is we're going to take the two equations, we're going to add or subtract them, one of the two, to try and eliminate one of the variables. If you eliminate one, that means you can solve for the other. And once you got one of them, you just plug it back in to find the other. This will make more sense when we do an example. So let's consider this. Here's two equations. And I'm going to rewrite them so one is above the other. And the x's are lined up. Y's are lined up. And the numbers are lined up. Could we add or subtract these equations and eliminate one of the variables? Do what? Add or subtract? Subtract. Because y minus y, nothing. So what I'm going to do is I'm going to subtract equation 1 by equation 2. Is these are gone. Y subtract y completely disappears. What is now? Be careful here. What is negative 7 subtract negative 4? Negative 3. Because negative 4 subtract negative 11. When you subtract a negative, that means add. So negative 4, negative 7 plus 4 is negative 3. Well, guess what? We found one of the answers. How do we find what y is? Plug it back into one of these. Which one do you want to put it back into? Number 1? Sure. So sub x equals -3 into 1. And then you solve for y. So 2 times -3 plus y equals -7 when I put it back in. Yep. How what? Remember, we're subtracting. So when we subtract -4, add. Yes. So this is -6 plus y is -7. Add 6 to both sides to get y by itself. Y equals -1. And you got your solution. So remember, we can answer it two ways. We can write it as a coordinate, or we could just write them separately. So that one was pretty straightforward because we could just subtract them to get rid of the y's. Sometimes it's not so straightforward. We might have to do some other stuff first. So here's another example. Equation 1, equation 2. Yep. And then you can subtract them?
Yeah, make the x.
Yep, we could do that. Okay. I'm going to show you how we can do it by subtracting and how we can do it by adding. Because sometimes students find it easier to add. Okay, but both work. So what we have to do here, I can't add or subtract right now and get rid of one of the variables, right? Because the numbers are all different. But what I could do is I could multiply each of these by some number to make the x's or y's the same. So how could I do that? Well, look at the x's. I could multiply this by 5, this by 3, and it makes 15 for both. And then I can subtract and get rid of the 15s, or the x's. So I could do 5 times equation 1 minus 3 times equation 2. What does equation 1 look like when you multiply everything by 5? And what does equation 2 look like when you multiply everything by 3? Now we can subtract the 2. Now remember, the subtraction has to apply to everything inside. So 15x minus 15x, gone. Be careful with this one. -20y minus -18y. Excellent. And 35 minus 24, 11. And we can solve for y by dividing everything by -2, and y equals -11/2. On a fraction, but not too bad. Now what? Yeah, plug this back into one of these for y and figure out what x is. Looks like it really doesn't matter which one. So I'm going to sub y equals -11/2. I'll just put it back into 1. and I'll solve for x. So when I do that, where's equation 1, 3x minus 4 times y, if y is now negative 11 over 2, equals 7. Multiply these two together and I get a plus 1. Because remember, here's a common mistake students make. They multiply the 4 by the top and the bottom. We don't do that with fractions. This is 4 over 1. So we get positive 44 over 2, which is just the same as 22. Now what? Yeah.
And that becomes negative. I mean, 3x equals negative.
And then we divide both sides by 3. X equals negative 5. So we say x equals negative 5, y equals negative 11 over 2, or we write it as a coordinate. Like so. Now, I'll put the page up. Some students like to do this. They don't like to subtract. They like to add. So what could we do instead? I'm going to do this. I'm going to multiply the first one by negative 5 and then add it to the second one. If I do that, I get negative 15x plus 20y equals negative 35, right? And if I multiply the second one by 3, I get the same as I did before. 15x minus 18y equals 24. Now I'm going to add. Yeah. So I can change this to add instead of subtract. I have to in order to get rid of something, there are two things. By adding, one has to be positive, one has to be negative. So that's why I had to multiply this. So if I add, and if I add these, I get 2y. If I add these, I get negative 11. Notice I get the same answer. And then we can just carry on as before. Some student, the advantage about multiplying by a negative and adding is you never have to worry about subtracting negatives and making that mistake. Okay, because here I've got to worry, oh, this changes to plus. I got to watch out for that. I don't have to worry about that when I add. Okay? So one or the other is fine. One or the other. Okay. Oh boy. Oh. That's something I don't like. Got fractions. I want to get rid of the fraction. What can I do to get rid of the fractions before I even start? Yeah. Let's multiply everything here by 6 and multiply everything here by, right. then we'll be left with one that looks like the previous question, which is much easier to deal with.
So 6/3 becomes, and times 2x becomes 4x, yes. 6/2. What? 6 divided 3 is 2, times 2x is 4x. Like, doesn't this become 2? And you still have a times 2x here, you've got 2x.
No, you're still not convinced.
Think of it like this becomes 2. Now I've got 2 times 2 times x.
Better?
Okay, good. And then we've got minus 6 divided 2. That's 1 times y. Minus 3y equals 6 times 4. 4 divided 2. 2 times 1 times x is 2x. 4 divided 4.
1.
Times 1 times y is just 1y, or y. 4 divided 2 is 2 times 5 is 10. Okay? We want to do adding or subtracting?
We want to do subtracting? Okay.
Make the x's the same. What do you have to do to one or the other equation to make the x's the same? Yeah, multiply this by 2, then you could subtract them, and the x's disappear. So we're going to take equation 1, subtract 2 times equation 2. So we get 4x minus 3y equals 24. And when I multiply the bottom by 2, I get 4x plus 2y equals 20. So those are gone. Negative 3 minus 2y, negative 3y minus 2y is negative 5y. 24 minus 20 is 4. Divide both sides by negative 5. Y equals negative 4/5.
And what do we do with that? Plug it back into one. I would suggest plug it back into one of these. Don't plug it back into one of these. You can, it'll still work. But to me, the less fractions, the better. That's just my preference.
So let's plug it back into equation 2. So we are going to substitute the y we just got into 2 so we can solve for x. So when I do that, I get 2x plus, instead of y, it's negative 4/5 equals 10. Well, plus negative is just the same as minus.
How do you want to solve that bad boy? Get rid of the fraction.
Times everything by 5. Nice. So 10x, those are gone. Minus 4 equals 50. It would be negative 10x. I think it's positive.
Unless you multiply by a negative to begin with.
Yeah, then yours will be slightly different. But it should still work out to the same. Add 4 to both sides. 10x is equal to 54. Divide both sides by 10. 54 over 10. 27 over 5. No, that wasn't a very pretty one. Or if you want to write it as coordinate, how did I get 2x? What? Which one?
Equation just did.
That's the equation I used.
Then why did we change the top?
What's that?
Why did we change the top one to 2? Because it was 4, but then we changed it to 2.
I don't understand what you're asking. This is a different way to write equation 1. This is a different way to write equation 2. So we use these and elimination to figure out what y is. You okay there? Okay. Once I've got this, I plug it back into one of these. So I decided to plug it back into this. So I get 2x plus negative 4/5 equals 10. 2x. Yeah? Okay. We're not going to do the last example, but we are going to do this one. Just like we did with substitution, this time we need to create the system and then solve it. And we'll use elimination. So, Ms. Wilkes decided to purchase M&M bags and Hershey bars for all of her students. Each M&M bag costs $3. Each Hershey bar costs $2. She bought 16 of the items for a total of $41. So out of all of that, I have to make a system, 2 equations. What are our unknowns?
The amount of M&Ms and the amount of groceries.
So M&Ms and Hershey bars. So just to be a little different with the letters, so I'm going to do M and H. You could do X and Y, it's fine. Okay. What are our 2 equations?
Y equals 6.
So with my letters, it's M plus H equals 16.
And 3M plus 2H equals 40.
There we go. So that takes care of part A. Part B, we're going to solve it. By elimination. Usually it's just look at the first variables. What do I have to multiply one or the other so that when I subtract, they're gone? Yeah, I got to multiply this one by 3, and then I can subtract them. So I'm going to multiply 3 times equation 1, and then subtract equation 2. So 3 times equation 1 is 3m plus 3h equals 48. Equation 2 I haven't touched. Subtract the 2, m's are gone. What do I get? 3h minus 2h. I'm not getting negative h. 3h minus 2h is h equals 48 minus 41 is 7.
But I'm not two.
3h subtract 2h. Right? Is 1h. So I already know the number of Hershey bars. It's 7. How do I find the M&Ms? Plug it into the first one. Sub h equals 7 into 1. Solve for m. Now, I put these instructions in blue because you don't have to write these when you do your solutions. Okay? I'm just showing you what I'm doing. So that means it's m plus 7 equals 13. Well, that's pretty obvious. M equals 6. Okay? Remember, we're in a problem situation, so you got to answer in a sentence. What's that? What? 16? Sorry. I thought it was 13. My mistake. 9. So there are 7 M&Ms and 9 Hershey bars. And that's my final answer. Okay. You have to know, just like when we did the graphing, I want you to know how to use a table of values, how to use intercepts, and how to use slope intercept. For this, I want you to know both substitution and elimination. Okay? So you can be asked, solve this system by substitution. Or you could be asked, solve this system by elimination. Whenever I give you a word problem, I'm going to ask you to solve it. You decide which one you want to use, which one you like better. Okay? Okay.